he has a lot of experience talking about gas and diesel power generation, energy storage, and renewable energy. And hope you will, I assume, I definitely feel that you will find his presentation interesting. Yeah, Jason, I pass the time to you.
Okay, thank you, Felix. Thanks a lot on your introductions. And this maybe today is a great time for me to catch up with Green Council events. Okay, maybe let me share my screen first.
Thank you.
Okay. So you can see my screen, right?
Yes, good. Thank you.
Okay. Okay. Thanks again on Green Council for giving us on sharing our view on the green technology and innovation on electricity generations. To start with my presentation, let me give you an introduction of our company, VPower Group, headquartered and listed in Hong Kong with subsidiaries in different countries. We are the largest genset system integrations provider in Asia, and the largest owner and operator of gas-fired decentralized power station in Southeast Asia, focusing in providing and operating the world-class genset and power generation stations and system for more than 20 years, which is including the investment on LNG to power, waste to power, biogas, biodiesels to power, etc. Our business network of supplying the clean power solution in over 20 countries or regions. Currently, our power generation assets in operation and development are over 2 gigawatts in our global power stations. And our global footprints, which is including, for example, Europe, which we have our subsidiary in UK, and Middle East with subsidiary in UAE, Latin American with subsidiary in Peru and Brazil. Asia, of course, we have headquarters in Hong Kong, and then subsidiary and factory in mainland China. Southeast Asia with subsidiary in Singapore and Indonesia. In Hong Kong, actually, we contribute quite a lot on backup power supply for data centers, for hospital buildings, etc. And of course, we also offering our solution on waste to power solution for example, for DST projects, landfill projects, and factories. And besides the standby power, waste to power, and we also offering our energy storage for example, for the construction site applications. We take green power solution for global project as one of our key development strategy, which have been recognized by well-known organizations during the years. There are some of our awards from different organizations. For sure, we will continue to put our resource in green technologies and environmental protections. We are committed to keep our improvement on business practice to achieve sustainability targets. We target to phase out pure diesel power projects by 2030 and achieve net zero by 2050. As an integrated expert in decentralized power generations, we have been putting our effort on R&D in order to materialize our responsibility to minimize the operation impact from our solutions and keep on invest in green technology and innovations, supporting our customer these decarbonizations with green energy solutions. Climate changes surely all of us are wearing the impact on the climate changes. Most important that no one can go away from the impact of those extreme weathers. However, we believe that green technology and innovation in power generation can improve the situations. In the coming few slides, let us look into the emission in Hong Kong. For example, from the government report in 2020, the total greenhouse gas emission is around 31,800 kilotons CO2, which is per capita emissions 4.5 tons per year. If you look into the four major sectors, you will see that energy will take the major percentage, close to 86%, including the electricity generations and energy industry, transport, use of the fuel for conversion of the commercial buildings. So let us zoom down on this energy sector. For example, from these larger electricity consumption sectors, we can see that from the report, 9% of the electricity used by the building which is including residential building, commercial building, and industrial buildings. Where 2/3 of this emission come from commercial sectors. It is a fact that we should play our role to decarbonizations. As we are in the field of power generations, we commit to keep on improving our technology, say for further improve on the renewable energy, increasing the efficiency of energy power. Later on from this slide, I'm trying to share our view on energy pathway from renewable energy down to the end user. Renewable energy resource means energy that is sustainable. Sometimes that is can't run away, just like, for example, sunlight, wind. There are a few types of the green energy, say solar energy, wind energy, hydro energies. However, the supply of green energy usually is not stable, mostly depending on the weather, which will create the unbalancing issue of the grid. For example, the renewable energy, we produce electricity and then through the grid and send to the end user. But as I just highlighted, because of the unstable of the renewable energy, for example, whether the windy is enough for the wind farm is totally depend on the weather. So in order to get the grid to be more balancing, we can add on the energy storage. Energy storage is the capture of the energy produced in one time for use at the later time to reduce the imbalancing between energy demand and energy productions. So basically, it is not only storage for clean energy, but also act as the balancing role of the grid. Currently, battery is the common way for energy storage. Another pathway of the renewable energy is we can make use it to produce hydrogen. Pretty sure that hydrogen is a hot topic for the green energy, which is most of the country are trying to put the resource on developing the hydrogens as a green fuel for many applications. For example, for transport, for power generations, industrial, and many other applications. If applying the hydrogen for the power generations, in in order to have the green electricity, the green fuel, we should apply the green fuel, for example, hydrogen, biogas, and currently in the most of the gas engine manufacturer over the world, there are few engine brands are ready for 100% hydrogen applications. But currently today, most of the engine are also ready blending the H2 with the natural gas. For example, 20% H2 blending with 80% natural gas as a fuel for the genset operations. By increasing the percentage of the H2, actually the CO2 can be reduced down to 0 from the gas-fired engines. Of course, besides the H2 and H2 blending with natural gas, green fuel can be the biogas. Biogas mainly come from the organic waste, for example, our waterways, landfill, and we can collect the biogas, this kind of biogas, as a fuel and provide for the genset operations. The genset power plant can produce the electricity in many ways to support our consumption. For example, you can directly send to the end user. For example, our community for the electricity consumptions, and of course, the power plant also acts as a continuous power supply to a factory which is really remote from the grid. And of course, another way is we can charge up the energy storage. Energy storage, actually, there's many applications can be applied. For example, we can use the energy storage into the construction site, which currently is mostly applying standby genset, but we can develop the energy storage to replacing the standby genset in the construction sites. And for the energy usage, one part is really important is increasing the efficiency of the energy power. For example, for the genset applications, we can include with the efficiency pack. Efficiency pack can be including the ORC, which is make use of the waste heat to power, and CHP, CCHP, which also make use on the thermal power to further producing hot water, steam, or through a absorption chiller to produce air conditioning. So this is also another way for us to increase the efficiency of the energy power. From this slide, I'm trying to share the energy usage. For example, for 100% energy fit into the genset, usually there is about only 43 to 45% of the energy power can produce into the electrical power. In a very traditional way, there are a lot of thermal power is waste into the environment. By new technology to capture the thermal power, we can further use this kind of thermal power for different ways. For example, for the ORC is a second generation make use on the waste heat to power and produce extra electricity. And for example, the CHP, CCHP also can further make use on the thermal power. By adding the application on the thermal power, the energy efficiency can be add up from 33% up to 88% or 93%. So this is another way for us to increase the energy power, which is also the ways to reduce the CO2 productions, CO2 productions. This is another case study on how to make use on the thermal power. As I just highlight, for example, 100% of the energy power fit into the genset. For example, for this case, we apply a M2 engines with 16 V4000, which is normally can produce 2028 kilowatts. But if we include with a ORC product, the ORC product can capture the thermal power, part of the thermal power, and then producing extra electricity. From this case, the ORC can produce 63 kilowatt extra as a 3 green energies. By this case, actually, the energy efficiency can be increased by 3%. So this is one way for us to increasing the energy power and reduce the production of the CO2 from the engine. And for the whole energy pathway, actually our company have our contribution on different sector. For example, the green energy, we are offering a solution on the solar power plants, and we also offering the energy storage with battery. We also touch on the hydrogen projects. Currently, we have some project in Europe and blending the H2 with natural gas for the genset operations. And we also are buying biogas for power gen operations. For example, in China, we have a biogas power plant for applying the biogas for the power plant operations. In Hong Kong, we also working with DSD for the wastewater power plant to apply the biogas, and also the landfill gas with CLP on applying the landfill gas for the power generations. Besides the power generation, we also offering the efficiency kits. I just highlight, for example, the ORC products, the CHP, the CCHP products. So by offering different kind or different sector of our products, we are helping the market to reduce the production on CO2 and step forward on the net zeros. So maybe today this is my presentations. Is really really focusing on the power generations. Hopefully, I can share some experience, and also I'm free to take up some question if any. So Felix.
Thank you, Jason. It is quite interesting about the green field on your presentation. In fact, there's a question is, according to your current plan, what will be your major field in power generation if the fossil fuel is phasing out in future?
Oh, okay. At the moment, currently in the long-term target, we are working on the hydrogen. We are working with engine manufacturer, and we have our R&D team to provide the solutions, power gen solution, applying hydrogens. But of course, in the short terms, we are applying the biogas as our one of the major field for our operations. Besides the biogas, of course, we also applying the natural gas as well. Yeah.
Okay, thank you. There's another question is
yes.
your technology pathway is a very perfect framework for a green power generation. It's very amazing. But what are the greatest challenges in achieving this pathway?
Okay, maybe I can go back to this pathway. Yes, you're right. Actually, the most challenges is the renewable energy. You know, as I highlighted, renewable energy is not stable. It's totally relying on the weather. For example, for our power plant in UK, we also have a power plant in UK, which applies the natural gas as a distributed power plant for supporting the grid. And if look into, for example, look into the grid in UK, they have quite a high percentage on renewable energy. For example, more than 50%. And they build a lot of wind farm and solar farm for renewable energy. But if look into their electricity supplies report last year, actually last year is really strange because the wind in second half of last year is reducing quite a lot by comparing previous years. That's why they are calling the production from the wind farm is reducing quite a lot and call the grid is not stable. I think if the whole pathway, the most challenges is how stable of the renewable energy for the grid applications. So that's why we actually in the market, there's quite a lot of energy saving product coming up, which is taking a critical role for grid balancing. No.
Okay, now it's very challenging. That is, although our first speaker, Henry, mentioned that the price of renewable energy is getting cheaper than fossil fuel, but you bring up another challenge is about the reliability.
Right. Reliability is really challenges, but of course, as today's topic, innovation technology can help quite a lot on getting the grid to be more stable.
Yeah, I suppose I believe you are the professional in driving those kind of innovation.
Yeah. For example, the energy storage. Actually, you know, you can imagine for some day there is quite windy, then the wind farm will oversupply on electricity. Then what to do for the grid? Because oversupply for the grid is also not a good, but we can make use the oversupply electricity and charge up the battery as a energy storage. Then also another way around to helping the grid to be more stable.
Okay. Yeah. And oh, sorry, there's a question. I think the time is almost up, but there's a question is, how will you anticipate the trend of fuel cell against rechargeable battery? What will be the ratio, do you think?
Right. Very good questions. You know, fuel cell, actually, the technology on fuel cell is not new. About 20 years ago, there's already company or country already put their resource on fuel cell. But right, fuel cell at that time is totally not economical because it's really high cost on producing fuel cells. But if look into the fuel cell production in last few years in Europe, actually the production on fuel cells, the cost reduced quite a lot by comparing 10 years, 20 years ago, but still in the really high size. But I believe because of the technology can help further reduce the cost for producing the fuel cells. In the future, if fuel cell can be mass production, actually fuel cell can basically replace engine. For example, the engine, the car, and power stations also can apply the fuel cell.
Okay, I think the time is, sorry about that, the time is up. I have to end your discussion.
Okay.
Yeah, but your topic is very interesting. And
thank you.
Yeah, thank you very much, Jason. And hope you can drive more innovation in those kind of green field.
Yeah, sure. And although today is really short for me to share the experience, but just contact us, drop me an email if anyone have this kind of question or maybe would like to share the experience with us, just contact us.
Okay, thank you.
Thank you. Thanks a lot.
And thank you for all the audience.